Hello, my name is William Lowe. This is my final capstone project for the Google Kaggle AI agent course. The project I have is a Safe Staff AI, early warning, staffing risk detection for emergency departments. The project solves two connected problems. First, it predicts ER wait time risk using XGBoost model trained on ER wait time datasets. This gives the system a base forecast of how long patients need to wait under a certain given scenario. The second, it uses the wait time prediction along with additional operational pressure signals to determine how many nurses it needs. Things like arrivals, surges, bed, boarding, patient acuity, staff, call-out, fatigue, and fast-track bottlenecks. If we go to the GitHub, my GitHub, in GitHub Draculus99 safe staff, there'll be two diagrams, mermaid diagrams. One where you're going to show that the components, how they're connected together when the system is being built. The second one is the data and decision flow for you to understand how the system works. So when the system boots up, it's going to do this bit. It's going to train the XGBoost model so it's ready for forecasting, and then it's going to load up these additional operation pressure signals right here, which is required for to determine the nurse staffing shortages issue. So let's get to the application. So when it boots up, it's saying we've basically loaded up the additional operation pressure signals. The system is normal. Here you can get the performance of the XGBoost model, where we are basically interested in the high critical recall, saying that 9 out of 10 times it can detect a surge in staff, which is required. So let's go ahead and say, right, when using the system, we want to create a shift, but we don't know how many nurses we need. So I already preloaded some scenarios, which is going to basically set our controls here automatically, so that's not to waste time, but these are for demo purposes. So go to a winter flu condition, and then we're going to, for that particular date, and then we're going to say, tell me how many nurses I need or don't need. This one, the winter surge, is going. I'm going to need 4 additional nurses. So when this part is saying critical, it's saying it may require extra nurses due to surges in our operational signals here, which we were talking about a few seconds ago. So between here and here, launching the multi-agent committee, which is going to basically decide which nurses you're going to pick. We are basically preparing the data from the wait time forecast and the operational pressure which we added in addition to the system to help us determine how many nurses we need. Before launching the agents, there are 2 approaches we can have. We can have it go rule-based system, which uses an expert system. It still uses the tokens, the agents, but here it's using an expert system with the agents, so it doesn't have to go use a large language model. The second one uses a large language model, so each of the agents you create is going to go out and basically debate the situation. So let's launch it. So it's going to basically show you a pipeline as each of the information is being passed to each of the agents, and they're going to come out with some outputs. There's also a pipeline to the left-hand side of the control, which shows you where in the pipeline we are in at that current situation. Critical means that we need to address a staff shortage in the system with the current condition. So it's gone ahead, and basically you have this executive summary. So critical approval required. You've got the additional research modules has detected that we have ESI pressure high. So here it's basically arguing out in the debate what the important items we need to basically look at when determining how many nurses, what nurses we're going to basically select in our system. This is a matrix of the existing nurses, and which ones will fail and pass the test before being selected. This basically mentions about the cost, how much you save if you basically select these 4 nurses. There's a cost optimizer where it can basically select the best nurses to reduce your cost here. Right here, the human, it's not going to go any further until the person approves it. So you can approve the optimal nurses which are selected, or it approve the original set which has not been optimally selected, or it could reject, or you can even basically change the nurses. If there's a problem with a nurse that's not available, not in the system, you can change it right here. Here we're going to submit the decision right here. So as we said, we're creating a shift. You see the shift is created with those nurses which we approved. Final decision executive summary. 4 nurses needed. Roster has been updated and audit recorded. Let's go to audit, and we can see the entry here and how much extra it's going to cost, whether the cost is actually broken down, and basically the nurses which are selected, how much it's going to cost you to hire them. So that concludes my walkthrough.